Hey guys, my name is Sandeep Patel. I'm founder of Slotify.ca. In this video, we are going to learn about the quick sort, which is a sorting algorithm used for array data structure. So basically, you can sort an array using array in ascending or descending order using this quick sort algorithm, right? And behind the scene, the quick sort follows divide and conquer technique. So first of all, we are going to learn about what is divide and conquer technique, right? Because if you don't understand that technique, there is no point of learning about quick sort, right? Okay, so first, what is divide? So in divide and conquer algorithm, there are basically three steps. First, you divide the problem. Second, you conquer the problem, and then you combine, right? So in the divide step, in this divide step, we are going to use a pivot element, right? And using pivot element, we can break problem into sub problems like left and right array, right? Once we have that left and right array, we can recursively sort them, right? And then after, at the last, we can combine those results. Okay, if you still don't understand, just be with me. I'm gonna be explaining this in really depth. Okay, let's understand divide and conquer in bit more depth. Okay, so let's say that there are three steps we know, right, in divide and conquer. So divide. So there in divide, you can use two ways. So divide step can be used in two ways, right? You can either divide array into a half, and then once you divide array into half, you get like left array and right array, right? So this we saw in merge sort, right? So merge sort is also divide and conquer technique, right, where we are using this halving techniques. But in the quick sort, we use pivot, right? So how are we going to use pivot? I'll show you in the next steps, right? So basically, in divide step, we are gonna use a pivot, right, mechanism to split the array, right? So that's the idea. And using pivot, we're gonna split array into left and right part, which becomes a sub problem, right? When you divide an array into two problems, basically you are creating two sub problems, right? And then you want to solve that sub problems, right? So when you keep dividing array, right, there should be a point where you stop, or you want to stop, otherwise you go in infinite loop, right? So at what point we should stop, right? So basically when array is an empty array, or maybe it has a single element, or maybe the array size become really small so that we can solve our problem, right? I see a lot of people talk about breaking problem into sub problems and solving sub problems, but they really don't teach how this problem can be divided into sub problem. But in this video, I'm going to be teaching you how you can take a bigger problem, divide into sub problem, and then solve the sub problem, right? So consider this array, like this is our big problem, right? So basically our problem is that given array, we want to short this, right? Uh, but how do we do that, right? So I want you to learn about the technique where we can divide this into a sub problem. Okay, so let's understand this. So let's take like two elements from the array, right? So if we take two elements, how easily we can solve these two elements, right? How easily we can short them. So when we have two element, right, let's say 5 and 3, in this case we know that the 3 is less than 5, right? So we always want to put value that is lesser on the left side, and the value that are bigger on the right side when we are sorting in ascending order, right? So in this case, we can just easily swap this value based on which one is bigger, right? The bigger value goes on right, the smaller goes on the left, right? So if we have an array with two elements, we can easily short, right? What about if you have a array element which is a single element? Can you say there's no other value to compare, right? So basically you can say that when you're given a single element, it is already sorted, right? So that is a base case, right? That's the smallest problem that we can have, right? So basically we took the big problem, we divided that problem into a sub problem, right? In this case, two element. And you can further divide that sub problem into a single problem, right? Like the base case, right? And if you do that, then it's easy for you to solve this problem, right? So in this case, let's say, let's use the pivot technique to divide the array into a subproblem, right? Okay, let's understand this. So given that this is an array 53842, how are we going to, so let's consider that the first element of the array, we can take that element as a pivot element, right? What is a pivot element? The pivot element is like, we're randomly selecting this element, but um, using this pivot element, we are gonna divide the problem, right, into a sub problem, right? And how do we do that? So let's say that any value that is less than 5, we put it on the left side. So what are those values from this array? 3, 4, 2, right? So these values are less than 5. So we're gonna create an array with the values that are less than 5, and we will put it on the left side, and on the right side we put the values that are greater than 5, right, which is 8 in this case. And now we have this sub problem that we want to divide into further sub problem, right? So in this case you have one element 8, right? So we cannot go further down, so we will return from 8, right? Just remember that. In here you still have 3 elements, right? So we will divide this into a sub problem again, right? So in this case we take the first element again, which is 3, and the element, so less than element that are less than 3 in this array are 2, and the greater than 3 are 4, right? So we put 4 on the right, and 3 and 2 on the left side, right? So now we have only single element left, which is our base case, right? So we're going to return from here. Okay, so what we do here is that, so we know that in divide and conquer we have 3 part, right? Divide, right? So how do we divide? So using pivot element, right? And then second is conquer. So in conquer, what we're doing is that we take the left and right sub problem, right, and we recursively short, right? So this means recursive short, right? And the last part is combine. So in this step, we're gonna combine those smaller problem, right? So combine smaller solved problems, right? Okay, so in this case we can say that we already return 2 and 4. Those are like really small problems. So let's say that at this point we got 2 elements which is already sorted, 2 and 4, right? So we put this, we take this 2 and 4 and return, let's say in here, right? So we have left element 2 and 4, but we still need a right element, right? So in this case we have this right element, this left element, we combine this here, but we also want to put this pivot element in between, right? So what we do is we will put 3 in the middle, right? So now the array is sorted 2, 3, 4, right? So idea is that you take the left array, you take the right array and combine with the pivot element, right? So that becomes 2, 4, 2, 3, 4, right? In here you already return 8, right? So now you have to combine this. So now this right part has only 8, right? So now we combine this in here, right? So we have 2, 3, 4. We're gonna add our pivot element, which is 5, and on the right side we have 8. So we put 8 there, right? So now our array is already sorted when we go from bottom to up, right? So in order to learn what is the time complexity of this code, we can definitely check out this tree structure, right? We had only we have a single array, then we divide it into 2, then we further divide it into two. So this is going in a tree, binary tree like structure, right, where each problem is divided into two sub problems, right? So let's say right now we have only two levels, right? 2 raised to 0, that is 1, so we have one element. 2 raised to 1, that is 2, so we have two sub problems to solve here. If we have more problems underneath, then we can say there would be 2 raised to 2, 2 raised to 3, and so on. So basically the height of the tree would be 2 raised to n, and we can say it's log 2 base, right? Because it's 2 raised to 1, 2 raised to 2, 2 raised to 2, those are log 2 base, right? So the number of levels or number of calls you get is a log of n base 2, right? Okay, so let's understand furthermore by writing the code. Okay, so let's write a function, so called quicksort, which take an array as an input. Okay, and then this returns a sorted array, right? Okay, console.log, we can say quicksort, and let's say let's take the same example, 53842. So we can say 53842, right? And we want to sort this in this order, right? 2 3 4 5 8, right? So this is how should be the result when we write the code and sort, right? Okay, so first of all, you have to understand, when we break down the entire problem into sub problem, then we solve the sub problem using a base case, right? So first of all, we write the base case first, right? And what is the base case? Single element. So when we have array with the single element, I would say array.length less than equals 1, then in that case we return the same array, right? Basically, if our array is a single element array, then we return right away. So that's our base case, right? Now in the first step is a divide, right? So in divide, what we do is we choose pivot element. And how do we do that? So we take the first element, right, as a pivot element. So pivot element would be the first element of array, right, which is array of 0, right? Now second step would be conquer, right? So in conquer, what do we do? Sorry, in divide we still have we have to find out the left and right part, right? So const left array. So how do we find the left array? So we take existing array, right, and then we run the filter method on that, and then we can say, okay, we have this element. If that element is less than pivot, right, this will create another array where all the elements that are lesser than pivot, right? And then we also have a right array, which is array.filter, and then this would say e greater than pivot, right? So now we have left and right array. So in conquer, what we do is sort them recursively, right? Sort them recursively, right? Or I mean subproblem, right? Create further subproblem, I would say. So how do we do that? So we can say, okay, sorted left would be quick. We call the same quicksort function and pass the left array, right? And then we also do sorted right, quicksort right array, right? And the last step would be the combine step. So we combine sorted left, right with pivot, right? So in this case, um, what we do is we spread all the left element first, then we put our pivot element. This is single element, so you can write like this, and then we can spread our right array, right shorted array, sorry, shorted right, and this should be shorted left. Okay, so this should work, right? So now our array is shorted. We initially are 53842. Now it's shorted in proper order, right? So next thing we will do is we find the time and space complexity of our problem, right? So for time complexity, what we do is we take each statement. For example, this is a statement, and this does not depend on the input array. So we can say this is 1 unit of time, right? This is also 1 unit of time. So when instead of writing 1 unit, I will say O1, right? Also, now this is important step, right? In here, you are basically dividing array into two parts, right? And then you're calling that function, and you're passing that half part on each side. So this basically you are creating tree structure here, right? Where you are calling this quick sort on. So you provided a single array, then you divide that problem into two, right? Left and right. So this takes O of log n, right? Why log n? Because it creates like a binary tree type structure where it divides single problem into two sub problems, right? And that's the reason why it's O of log n. This is a call stack, right? And call stack that takes log of n, right? And finally we will create a copy, right? This is basically we're spreading and creating a new array, right? Which takes O of n, right? So to find out the whole complexity of, we ignore O1 because even if you multiply 1 with log n, it's gonna be log n, right? So what we do is n times log n, that is our time complexity, n times log n, right? And for the space complexity, we check if we're using any variables, right? So in this case, we are not using any local variables. However, the call stack, this part, takes up some space, right? And so that is the space that we're worrying about, right? So we know that it takes log of n as a space complexity, right? Basically, we're counting this space complexity. We're not using any other space here. So that's why space complexity is log of n coming from the recursive stack, right? And the main time complexity is coming from this copy and the call stack, right? I hope you like this video. Please like, comment, and subscribe.